we get to talk all about greatest common factor. We get to talk about a strategy to use to identify our greatest common factor. And the way we're going to do that is kind of like a T-chart. So whenever we were doing prime factorization, we talked about factor pairs. And we listed our factor pairs, and I talked about how it kind of loops back around and makes like a horseshoe method after you list them all out. And you start getting to a point where your factor now is just flip-flopped. And instead of writing them all over again, we just kind of loop around, we go back up. So you'll notice over here that I have my product at the top, and then I have factors on either side. So we're going to go through this first page of notes together. This one should be on page, hopefully, 18, I think. Okay. It says the first pair is always going to be 1 and the product. So you're always going to start with the factor pair that is 1 and the product itself. Then you can try other numbers. Remember your divisibility rules. So we talked about those several weeks ago. You have the notes in there that you can refer back to if you forgot them. If a number is already listed in your T-chart or it's a twin, that's when you stop. Okay, so like 100 has a twin. What would the factor pair be for 100? That's the twin, 10 and 10. So do you see what I mean when I say twin? Okay, so like 25 has a twin, 5 and 5. So those are going to be the twin in the quotation marks down there that it's referring to. Okay, we want to make sure we list all pairs of factors. Okay, so what we're going to do is we are going to look over here at the right side first, where the giant T is, because we're using a T-chart. And it says use a T-chart to list your factors. We're going to practice it with 4. So the first thing that I want to review with you, just common factor, we just defined that. A common factor is a number that is a factor of 2 or more numbers. So for example, you have 2 times 3, which is 6, but you also have 2 times 2, which is 4. My common factors, and both of those would be 2. So now we're going to practice listing factors. 4 is a very small number, so it's not going to be a lot. But I'm going to start with 1 and the number itself, 4. What would my next factors be? 2 and 2, and those are what we call the twins. So there's no sense in listing 3 or listing 4 because I've got to a twin. But if I also get to a repeat, okay, that's when I would stop. So if I don't have any twins, but if I get to a repeated number that I've already listed in my T-chart, then I can stop. I don't need to go any further, okay? Okay, so now, because these are twins, I'm just going to put these are twins, stop. I'm just making that note. That's how we know to stop. That's how we list factors. So now we're going to actually practice finding the GCF. So when you find GCF, I say that a lot. Instead of greatest common factor, it saves time. GCF. So when you hear me say that, that's what I'm talking about. To find GCF, I'm always going to have at least 2 numbers, at least 2. Could I find the greatest common factor of more than 2 numbers? You bet. But right now for practice, we're just going to practice with 2 numbers. So we're going to start by listing all of our factors for 36 and 48. We're going to start over here on the side. So in a T-chart, starting with 1 and 36, then 2 and 18. Can 3 work? 3 and 12, 4 and 9, and then 6 and 6. And here's my twin pair, so I can stop there. Okay, now I'm going to do the same thing for 48. 1 and 48. 2 and 24, 3 and 16, 4 and 12, 6 and 8. The next digit up would be 7, but I know 7 does not divide evenly into 48, and the next number after that would be 8. So this is where we have the repeat, and that's why we stop. Is everybody kind of seeing how that works?
Yes.
Cool. All right, so let's list out our factors. We're going to stack them on top of each other. So we're going to take all of my factors and go in this horseshoe method and list them out right here. So I have, whoops, 1, 2, 3, 4, 6, 9, 12, 18, and 36.
1, 2, 3, 4.
And then they do the same thing for 48. 1, 2. I'm not going to say them out loud. I don't want to mess you guys up.
1, 2, 3, 4, 6, 8.
Okay, so what I'm going to do now is I'm going to look and I'm going to circle all of my common, all of the common factors.
Oh, common.
So the ones that they have in common are all of these factors. 1, 2, 3, 4, 6, 12. Any others? No, that's it. So all of my common factors are 1, 2, 3, 4, 6, 12. Guys, we're breaking it down like this now. I don't expect you to do this every single time because it's a lot of work and you can save yourself time, but I'm breaking it down so you understand how it works, then you can shorten it. So what is my GCF? 12. My greatest common factor out of all of the ones listed is 12. Okay, you and your tables try the next one together. Have everything on your paper just like how we did.
1 and 21. No, 2, not 2. There's only 1, which is 21. I know. It's okay. 65. Yeah. Nobody can That's good though.
When you think you're good, check and see if you got it right.
Only 1.
If I have it, you should have it on your paper too. So if you left something off, add it in.
Factor is 35.
If I have it, you should have it.
Wait, how's the greatest common factor?
Be sure, please, that you add in anything that I have that you left off. I want your notes to match what we're doing right now together so that you have good, solid notes to refer to. I have my answers up there, so check the board to see if you did yours correctly. If you made a mistake, fix it. Okay, let me see thumbs up, thumbs sideways, thumbs down, how we're feeling so far.
I'm good.
Okay, lots of thumbs ups. Okay, couple sideways. We're going to do a little bit more practice from our book.
Goes down.
I'm going to leave this up here for about 30 more seconds, and then we're going to move on. Okay, we're not going to spend much time on this page here. I just want to review with you real quickly what a Venn diagram is because you're going to see it again. I think I did take these problems out. Oh, listen. Okay, I did take these problems out of your practice, so you're not going to be doing the ones that have Venn diagrams, but I want you to understand how they work. When you see something like this, I have factors of 12 on the left, factors of 15 on the right. The ones that they have in common are in the middle. Okay, so that's how they're using this Venn diagram to break up all of my factors. The common factors go in the middle. Of those common factors, you can identify easily the GCF. Okay, that's all they're doing there. So what would my factor, if you're looking at this Venn diagram, what would my product that I started with, what would that starting number be? What do you think? Over here, the starting number would be what? 6. Over here, what would my starting number be? 9. So 3 is a factor of 9, 3 times 3, and then 2 times 3 is 6, but they both have 3 in common. What would this one be? This one has more numbers. This one over here on the right side would be 55.
5.
What might this one be? These are all of my factors of the number. And the common factor is 5. So I have,
It's 180 and 55.
okay, so this is prime factorizations of two numbers, right? Okay, so how did you get that? What did you do?
Because I multiplied them all together.
Yeah, you multiplied them all together. They're prime factorizations. So if we multiply all of these together,
180.
okay, it'd be 180. Now it says identify the pairs of numbers and then explain. I think sometimes we understand how Venn diagrams work. Sometimes when we start trying to work backwards from a Venn diagram, it can get confusing, which is why I took these problems out. I don't think they're bad. I think sometimes it's just, I'm trying to make sure you understand how to find greatest common factor. And sometimes we're asking in ways that might start to confuse you. And I just want to know that, do we have the concept down? Do we know how to find greatest common factor? That's the important thing. Okay, that's why we're not spending a ton of time on this entire page. Okay, here's where we're starting for real. We have already looked at how to find GCF on the notes page that we just did. Okay, they list them out straight like this, and then they circle all the ones they have in common. Okay, it's telling you right now the GCF of 24 and 40 is 8. It's also giving us an example of using prime factorizations to use GCF. So this kind of goes along with that Venn diagram method we just looked at. So if I'm using prime factorizations, I would take all of my prime factors of 12, and I have 2, 2, and 3. Of 56, I have 7, 2, 2, and 2. So of that, my prime factorizations for both of those numbers, I have 2's in common, 2's in common again. You still circle all of the numbers they have in common on top and bottom. But then you have to go one more step, and you have to say, okay, 2 times 2 is 4. So the GCF is 4. So it's a different way of doing it using prime factorizations, okay? I'm gonna go back. All right, let's look at some practice. It says at the top, and this is in your journal on page 19, number 1 and 2, we are finding the GCF of the numbers using lists of factors. So this is what we just did. So you can just list out your numbers. Okay, example 3. It says find two numbers with a given GCF. So it says which pair of numbers has a GCF of 15. So if I'm looking at each one of these, I want to know which one of these numbers has a GCF, greatest common factor of 15. Can 10 even have 15 as a factor?
No.
No, A is automatically out. Okay, it's talking you through all of this in example 3. Okay. For C, 21 and 45, 15 is not even a factor for 21. That's why it's telling me that I can eliminate choices A and C right off the bat. Okay, these are going to be wrong. Choice B, factors of 30, here they are. Factors of 60, here they are. The GCF of 30 and 60 is 30.
B and D.
So it has to be D. So it's just walking you through, and you'll have this in your book to help you, and you can reference it whenever you get to this part in your practice. But we're going to go ahead and we're going to try both of these. So we have 5, 6, 7, and then we have 8, which is very similar to what we just did. So 5 through 7 says write a pair of numbers with the indicated GCF. So what two numbers might have a GCF of 10? What could I use? This is kind of open-ended, so there's multiple answers.
10.
10 would probably need to be one of them. You can create that T-chart, or you can list them. Remember I said we were breaking it down into all of these steps to learn it for the first time so we understand how it works. You can shorten it, and that's what we're going to do right now. We're just going to start by listing our factors for 8. A lot of times I like to put my product first, and then I start listing. once I have them listed for number 1, I can circle all of the ones that I have in common. And what's my greatest common factor?
4.
It's going to just be 4. Right. You can try number 2. You can check with your group mates on number 2 once you think you got it. Okay. So on number 1, we got GCF of 4, but on number 2, I have a ton of factors for 72 that I have to list out. You want to make sure each one of them has a match. It has a buddy, okay, because we're doing factor pairs. So on this one, just because of room, I had to make 2 rows of factors for 72. So I have 1 and 72 that are a factor pair, 2 and 36, 3 and 24, 4 and 18. 6 and 12, 8 and 9. Now of all of those, I'm just going to circle my 1s, my 2s, my 3s. I have 6, 9, and 18. So what's my GCF going to be?
18.
Right, GCF equals 18.
I don't even know where to list it.
Okay, on the next one, let's try these with the prime factorization.
Wait, I'm not done.
So this is just like the second example that then took it a step further with the Venn diagrams, but we're going to stop just with the prime factorization. So we're going to do a prime factor tree for 20 and 45. If you like upside down division, you can do that. And then we're going to use those prime numbers to figure out what my GCF is. So we're going to do this together. Starting with 20, I could do 10 and 2, and then 5 and 2. And then 45 might be 5 and 9, and then 3 and 3. Are we feeling okay with factor trees still?
Not yet. I am.
Okay.
I'm good.
Just factor trees in general.
No. Yes.
Yes.
Breaking it down.
I like the
Not really.
So with 20, I color coded the 20 as blue. So everything in blue is going for the 20 so that you can see it a little bit better. So I broke 20 down into 10 and 2 as a factor pair, and then I broke 10 down because it's composite into 5 and 2. They're both prime. So now I have my prime factorization for 20 and my prime factorization for 45. So my factors for 20, I'm just going to list my factors for 20. My prime factors are 2, 2, and 5. My prime factors for 45 were 3, 3, and 5. Okay, which one? Now I only have, out of both sets of prime factors, I only have 5s that repeat. So what does that mean my GCF is going to be? Right. I don't have to multiply those 5s together because I only have one group of common factors. The reason in our example earlier we had to do 2 times 2 was because I had 2 sets of 2s that were grouped together. Okay, we're going to do 32 and 90. I'm going to do this one together with you also. So what would some factors be for 32? What could I list first? 8 and 4?
16.
Sure.
2 and
Are
16.
either of those prime?
Nope.
Nope, so I got to factor both of them down again. So 8 would be 4 and 2. And then 4 would be 2 and 2.
You can do 16 and 2. And no.
Yeah, you could do that too. Remember, there's more than one way usually. And then you got to factor 4 down to 2 and 2. Okay, so I'm going to list all of my prime factors. So I have 2, 2, 2, 2. I have 5 of those. Okay, now we're going to go over and do the 90. And I'm actually going to write 90 over here so I have more space.
3 30.
Okay, 3 and 30.
I did 3 and 10.
There's more options, guys. You don't have to do 3 and 30. You could do 45 and 2. You could do 9 and 10. Okay, this will be 5 and 6. 5 is prime, 6 is not. So 6 goes down further into 3 and 2. So I have 2, 3, 3, and 5. What are my common prime factors? 2. So in this one, my answer is going to be, ooh,
That's right?
2. Yes, GCF is 2. Okay, you have 2 completed examples. It's a lot of work. Which method do you like better?
I like 3.
Okay, so some of you like the prime factorization method better for finding GCF. I like the list method because it's quicker, and I just want to go. I just want to get my stuff done. But prime factor trees are fun. They are fun. It's kind of a lot of work to do it this way.
I got 5 for my GCF.
I don't have 5 on the top row.
Oh,
Yeah, I did that too. I did 5.
Okay,
No, it's you listed it wrong. I listed it wrong. It was.
I'm going to leave this up for about 20 more seconds, and then we're going to move on. Page right here, because I have it over here. So I could use 10 and, well, I have to have 2 numbers because I'm finding GCF. So it's got to be 2 numbers. 10 and what? 10 is a factor of 10. Greatest common factor. So I want to list 2 numbers that have a the greatest common factor is 10. So think of numbers that have factors of 10. 20. So 10 and 20 could work.
30.
Could 20 and 30 work?
No, because 15.
But is 15 a factor of 10?
No.
So 20 and 30 could work.
Oh, yeah,
You're
right.
thinking of numbers that you could list where the greatest common factor is 10.
9 could be 3.
Okay.
9 could be
Okay, so let's look at number 6.
9.
Wait, did we only write 10?
10 and 20. Yeah, I mean, there's tons of number combinations you could do. We just did 10 and 20.
9.
Okay, number 6. My greatest common factor is 3. So of 2 numbers,
9.
okay, I could use 9 and 6.
Yeah, 6 and 9.
Could this work?
Yes.
Think about my factors of 9. 1, 3, 9. My factors of 6. 1, 2, 3, 6. 3 is the greatest common factor. Will that work? Yeah. What about 6? Y'all try that one with your tables.
6 and 9.
12. Yeah,
12 and 6.
No, because. Yeah, it could be 12.
I don't get it.
What about 12 and 18?
What about
Class.
Oh, what about?
Okay, I forgot we're supposed to switch at 55 after. 6 and any other multiple of 6 could work. 6 and then any other multiple of 6.
What about 12 and
Okay? Or you could do 12 and 18 could work.
Yeah, we did 12 and 18.
There's a lot of different combinations. Okay, we're going to stop here. We'll finish tomorrow. Okay, I just didn't mark it on here. All right, so the number that's not a factor of 10 should be C. You can either color it in or just circle the whole thing. Doesn't matter to me. Okay, so guys, I have 45 stickers, 30 colored pencils, and 15 bouncy balls to make gift bags for your friends. You want identical groups of items in each bag with no leftover items. It's very similar to the piñata question. What's the greatest number of bags that I can make? So I could do prime factor trees, and I could do all my prime factors, or I could just do all factors. So I like the list method, but if you like something else, you can do that method instead. Okay, so we're going to do 45. I have 30 and 15. So I'm going to list out all of my factors for each of these three numbers. So I have 45 and 1. So 1 will be my first one. Can I divide 45 evenly by 2? What about 3? Yes, I can. What about 4? 5, yes, because it ends in 5. 6 is a no. 7, no. 8, 9. That's my first factor pair right there, 5 and 9. So then 3 times what is 45? 15. And then 1 times 45. Okay, that's my factors for 45. Let's do the same thing for 30. I have 1, 2, 3, 4, 5. Here's my first factor pair, 5 and 6. Now I'm just matching up with what I already have. 3 and 10, 2 and 15, 1 and 30. And then my factors for 15 would be 1, 3, 5, and 15. And then I go back and I circle all of the ones that I have in common. So I have 1s, 3s, 5s, and 15s. So what's the greatest number of bags that I can make? 15 bags. Yes.
Are you going to do the tree?
You can do the tree factor method too. When you do the tree factor method, you are getting down to all of your prime factors. So let's see what that would look like so that we have both examples. This is the list method that we just did together. If I write, you write. This is our last one that we're doing together. So if we do the tree factor method, I'm going to have 45, 30, and 15. Okay, I'm going to do factor trees for each one. So 45, what could I use as my factor pair?
9 and 5.
Sure, 9 and 5 is great with me. And then 3 and 3. Those are prime, so I'm done. Then I could do 10 and 3 for 30. You could also do 5 and 6 or 15 and 2. And then break this out to 5 and 2, which are also prime. And then 15 would be 3 and 5, which are both prime. And then I got to list all of these out. So for 45, I have 3, 3, 5. For 30, I have 2, 3, 5. And for 15, I have 3 and I have 5. Now remember, there is an extra step you have to do with this one. Okay, I'm looking where they all three have something in common. So I have all of these in common and I have all of these in common. Do you remember what that last step was? If I have the 3 and the 5, what do I have to do with the 3 and the 5? I got to multiply them. So I would do 3 times 5 to get 15 as my GCF. So GCF equals 15. Either way you do it, you just have to remember to multiply. If I have more than one number that they have in common on the prime factor one, just need to make sure I multiply those together, okay? Going back to our page, we're almost done. We have an example, and it talks about a piñata and filling the piñata with gifts. It says that we have 18 kazoos, 24 mints, and 42 lollipops. It says the GCF, well, the question says, what is the greatest number of piñatas that I can make? So if I want identical groups of gifts in each piñata with no gifts left over, then what's the greatest number of piñatas that I can make with what I've got, with all of the gifts? So I've got all these little piñatas. I want to put the same number of things in each one, so how many can I make? Okay, that's a GCF type of a question. So what it's doing is it's listing all of our factors of 18, factors of 24, and factors of 42. What's special about those factors that they've listed? What do you notice about all of those?
They're all prime.
They're all prime. So they did the prime factors of all of the ones that are listed there. Okay, could you list out all of the factors for 18, 24, and 42, not just prime factors? Yeah, you could. Okay, so you have options. You pick what you like. We talked about that yesterday. Choosing the method that you like. If you like prime factoring for GCF, or if you like just listing your factors for all of them, including the composite ones, that's okay too. You're going to get to practice both today, but when you get to your test and you have the choice, you just pick what works best for you, okay? All right, so the GCF of 18, 24, and 42 is 6. That means that I can make 6 piñatas. So we're going to go through one of these. We're going to do it together. It does show you that Venn diagram again. It's showing you all of the factors of 18 that are prime, factors of 42 and 24. So you can still see that Venn diagram example. Okay, so my questions